If you've ever fixed a bug and immediately moved on, you're not alone. We all do that as juniors. But seniors stop doing it after they've felt the pain of production bugs and realized how much impact a single bug can have. So let me ask you something, and I really want you to think about this for a second. When a bug shows up in production, what's your first instinct? Do you immediately rush to fix it as fast as possible just so you can move on, close the ticket, and breathe again? Or do you pause, feel that pressure a bit, and start asking deeper questions like, why did this bug happen? What allowed it to slip through? And what else could break in a similar way? Most of us, especially early in our careers, choose the first option, and honestly, that's completely normal. You're under time pressure, you want to prove yourself, you don't want to be the person blocking the team. But this exact moment, the moment a bug appears, is where the mindset difference between junior and senior developers really starts to show. As a junior developer, when a bug hits production, your mind immediately shifts into survival mode. You're not thinking about architecture, long-term impact, or edge cases. You're thinking about one thing. How do I make this error go away as fast as possible? You jump straight into the logs, follow the stack trace, scan the code for anything that looks suspicious, and try to apply the quickest fix that can stop the bleeding. And the moment the application starts working again, you feel this wave of relief because the pressure is gone, the alerts stop, and you can finally breathe again. That feeling makes total sense, especially early in your career, when you're trying to prove yourself, avoid slowing the team down, and show that you can handle problems under pressure. But here's the part we rarely talk about. In that moment, there's almost no space left to step back and ask deeper questions. Why did this bug exist in the first place? What conditions allowed it to reach production? What other parts of the system might fail in a similar way? The goal isn't understanding, the goal is speed. And over time, this trains you to think very locally, line by line, fix by fix, instead of seeing the system as a whole. It works in the short term, but it quietly sets a ceiling on how far you can grow as a developer. The problem with this way of thinking isn't that it's wrong. It's that it quietly creates problems you don't notice at first. When you're always fixing bugs as fast as possible, you start optimizing for speed instead of understanding. Each fix feels like a small win, but over time, those small wins stack up into technical debt. The codebase becomes harder to reason about. Edge cases pile up, and the same types of bugs keep coming back in slightly different forms. You might notice that you're always busy, always firefighting, yet somehow the system never really feels stable. And this is where frustration starts to grow. You fix the same issue again and again, your confidence takes hits, and you begin to feel like you're constantly reacting instead of actually improving anything. From the outside, it can look like you're productive, tickets are closed, bugs are fixed, but internally, the system is getting more fragile. And the most dangerous part is that this cycle can feel normal. You get used to the chaos, the late alerts, the last-minute fixes. But staying in this mode for too long doesn't just affect the code. It affects how you think as a developer. It trains you to see bugs as isolated incidents, not as signals that the system itself needs to change. This is where senior developers start thinking differently. When a bug shows up, they don't see it as something to get rid of as quickly as possible. They see it as a signal. A signal that something in the system isn't behaving the way it was intended to. So instead of asking, how do I fix this bug? The first question becomes, why does this bug exist at all? They trace the data flow, not just the failing line of code, but how data moves through the system, where assumptions are made, and where things can silently break. They actively look for edge cases, not because they enjoy complexity, but because they've learned that edge cases are where systems usually fail in production. And they review the assumptions behind the code. What inputs did we expect? What behavior did we assume? And what happens when reality doesn't match those assumptions? To a senior, the bug itself is rarely the real problem. It's just the visible symptom of a deeper issue in design, validation, or understanding. And once you start seeing bugs this way, your goal shifts completely. It's no longer about making the error disappear today. It's about making sure this entire class of problems never shows up again. Now, think about the last production bug you fixed. What did you actually do after it was resolved? Did you just close the ticket and move on? Or did you change something so that bug could never happen again? This is where senior developers slow down and get intentional. They add validation so bad data never enters the system in the first place. They improve error handling, not just to avoid crashes, but so the next failure actually tells a clear story. They refactor risky or confusing logic, even if it technically works, because they know unclear code is just a future incident waiting to happen. They add tests, not to feel productive or hit coverage numbers, but to lock in behavior and protect the team from repeating the same mistake. And they set up logging and monitoring so the system can warn them early, before users start complaining. None of this feels urgent in the moment, and honestly, it's easy to skip when you're under pressure. But seniors choose to do it anyway, because they've learned that every shortcut today becomes someone else's emergency tomorrow, often their own. When you step back and look at it, this is really what the senior mindset comes down to. Seniors focus on root causes, not because they enjoy digging deeper, but because they know that surface-level fixes don't scale. They think in terms of long-term stability, not just whether the system works right now, but whether it will still behave correctly months from now, under pressure, with more users and more data. And over time, this way of thinking leads to fewer incidents in production, fewer late-night alerts, and fewer moments where the entire team is scrambling to fix the same type of issue again. The system slowly becomes more resilient, not perfect, but stronger and more predictable. So here's the real question for you. The next time a bug shows up, will you ask yourself, how do I fix this quickly? Or will you pause and ask, how do we stop this entire class of bugs from happening again? That single question, more than any framework or language, is what separates senior developers from everyone else. Let's put this side by side, because this is where things become really clear. On one side, you have the junior approach, fixing the bug that's right in front of you, thinking locally about a single function or a single line of code, chasing short-term wins just to get things working again. It's reactive. Something breaks, you respond, and then you move on. On the other side, you have the senior approach, preventing the bug entirely, thinking system-wide about how different parts interact, and optimizing for long-term reliability instead of quick relief. It's proactive. You act before the next failure happens. Now here's the important part. This isn't about good versus bad developers. Most of us move back and forth between these two modes, depending on pressure, deadlines, and experience. So as you're watching this, ask yourself honestly, in your day-to-day work, are you mostly reacting to problems, or are you actively shaping the system to prevent them? That answer tells you far more about your mindset than your job title ever will. This difference isn't just about cleaner code or nicer architectures. It has real consequences in real life. Production bugs cost money, sometimes directly, sometimes quietly through lost users, missed opportunities, or teams being forced to drop everything to fix the same issue again. And when the same types of bugs keep coming back, trust starts to erode, not just from users, but inside the team itself. Product managers hesitate, stakeholders worry, and engineers lose confidence in the system they're responsible for. Now think about how that feels when you're on call, getting alerts late at night for problems you've already fixed before. Prevention changes all of that. It saves time, reduces stress, and gives teams the space to actually build instead of constantly firefighting. And this is why mindset defines seniority. Seniors aren't trusted because they write clever code. They're trusted because they reduce risk, protect the team, and make the system safer for everyone who depends on it. So ask yourself, if something breaks tomorrow, will people trust you to not just fix it, but make sure it doesn't break again? If you want to start thinking more like a senior, it doesn't begin with a new framework or a more advanced language. It starts with better questions. The next time something breaks, don't just ask, how do I fix this? Ask, why did this happen in the first place? Look beyond the single failing line and try to understand how data flows through the system. Think in terms of edge cases, the weird scenarios users will always find but tests often miss. Designed for failure, because failure isn't an exception in real systems, it's guaranteed. And most importantly, optimize for humans, not just machines. Write code that your teammates can understand under pressure, at 3 a.m., when something goes wrong. This mindset doesn't change overnight, and that's okay. Seniority isn't about knowing everything. It's about taking responsibility for what happens after your code ships. So if this video resonated with you, take one bug you fixed recently and ask yourself, did I just move on, or did I make the system better for the next person?